Audio Jungle. Audio Jungle. Audio Jungle.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for today, we want to present DBM20023 Engineering Mathematics 2. This presentation is for two by group for me and my members. Okay, group presentation for we got the title is integration. Okay, I want to introduce my members is my group members is Muhammad Akita Kyudin, Azam Bahaki, and our big brothers is Rozaimi and me, Muhammad Aikal Birazali. Okay, today we will present how to solve the question about application of integration area and volume.
Okay, before we solve the question, we look at the introduction to application of integration, area and volume. Before we learn integral, we learn about its derivative, or we know dy over dx. And for integral, we know the sign of worm or sign of integral y over dx. The derivative, we get the rate of change and the gradient, but for integral we get the area. So the area actually for volume, we use the volume of cylinder. Okay, v over pi r square h, which h is integration limit, and r we replace with the function f over x or f over y. Okay, to solve the question, generally we can use three steps. The question of integration. Number one, we sketch if the question does not give any paragraph. And number two, we identify integral. After that, number three, we combine. We combine means that we combine another maybe curve and straight line. And conclude, which means that we get the answer.
This is the question that we try to solve today. Question number 4, area. Determine the area of the region between the two curves by integrating over the y-axis. The question is also given a graph. And for question number 2, volume. What is the volume of the solid generated when the region enclosed by y equal to square root sy equal to 3 and s equal to 0 is revolved about the y-axis? And a graph also given for this question.
Thank you for my group partner, Tahyuddin, for the presentation. Next, we continue our presentation with the next slide, which is calculation method for question 4. And the question 4 is determine the area of region between the two curves by integrating over the y-axis. And as you can see in the slide, we have the graph diagram. And from the graph diagram, we can get the two equations. And before we solve the number 4 area equation, let's assume that the first equation is x equals to y, which is we can assume it as fy equals to 9. And the second equation is x equals to y square, and we can assume it as gy equals to y square.
Thank you, Azam. We go to slide number 4. Okay, the question 4 is about the area. Okay. First, I want to read the question is determine the area of the region between the two curves by integrating over the y-axis. We must find the gy in the diagram is equal y2 and fy is equal 9. Okay, after we assume the fn and gn, to solve this question, first we find the crossing point between the fy and gy. Crossing point when fy equal gy, y power 2 equal 9, y equal square root 9, and we got the answer of y equal positive negative 3. Therefore, the crossing point at coordinate is 9, negative 3, and 9, 3. And the limit for integration is lower limit equal negative 3, upper limit is equal 3.
Okay, we continue to solve this question to the second step. Okay, what we want to find is the color area, which is the right equation is x equal to 9 or function y equal to 9, and the below or left equation is equation g y equal to y square. So we name the area with a. Okay, a equal to area under a straight line. Okay, we minus with area under a curve. So we must use integral with the minimum limit and maximum limit, which is integral from minimum limit to maximum limit of function y minus function gy, okay, function g dy. Okay, after that we substitute the value. Integral from minus 3, which if minus 3 is the minimum limit and 3 for the maximum limit of 9 minus y square dy. So we get the equal to 9x minus y cubic per 3 evaluated from minus 3 to 3. Substitute their value, so equal to 36 unit square.
For the second question, number 2 volume, firstly, we may add subjects of equations reaching fx to fy, y equal to square root of x. So square root x equal to y, x equal to y square, so fy equal to y square. Second step, find the limit for integration. Based on diagram, lower limit equal to 0 and upper limit equal to 3.
Thank you for my friends like you did for the presentation. And then we go to the next slide, which is calculation method for question 2. And the third step is calculate the volume, and then we got the formula here, which is v equals to pi integral maximum limit and minimum limits. Then we have fy square dy, and then pi integral to 0 and y squared multiplied by square dy, and then it will be pi integral to 0 y square root 4 dy, which is we had simplify the equation, and then it will become x pi y square root 5 divided by 5, and the integral value 30, and it will become pi equal pi open bracket 3 square root 5 divided by 5 minus 0 square 5 divided by 5, and we got the answer is v equals to 48.6 pi cubic unit.
Thank you, Azam. Again, we got the conclusion for this slide, and this my last slide, and for this sem. Okay. Firstly, by using the integration of a equal integration 3 negative 3 9 minus y power 2 dy. The area and we got the area equal 36 units, 36 unit, and in the 36 square units. Okay, secondly, for the question 2, by using the integration of equal pi integration 30 y power 4 dy, and we got the volume equal 48.6 pi unit volume, and in the cubic unit we say that 48.6 pi cubic unit. Okay, and for me the last for our members, and last we want to say that thank you madam for teaching for this sem, and hope madam can see us, and this last presentation for us and class DEP2B. Thank you madam.
Thank you all and see you again. Bye.